If you want to, feel free to, okay, perfect. Feel free to follow along just with the screen share, but also if you want to access these slides, whether to follow along on there right now or as a reference later, they will come out in an email, but you can access them with the bit.ly there at the bottom of the page. It's just bit.ly/ and 831, that's the date. Today is August 31st, so 831 and then capital C, capital S. And that will get you access to these slides. And I will tell you, there are a lot of links in these slides that hopefully will be useful to you after today's session. And you can refer to them whenever you are working. So that bit.ly will be available again at the end, and we will send this out with the recording so we can get this to you. But it's just bit.ly/ 831 capital C, capital S. So today we are going to talk about getting started with K-8 computer science standards. Now, if you have joined us and you are not in the K-8 space, maybe you are in high school, in the high school space, that's okay. We're really going to focus on these computer science standards at the beginning of this presentation, just to help really break them down, understand what the different components are and the different practices, so you will still benefit from your time with us today. Where the K-8 comes in is talking about ways to incorporate these standards into classrooms, into content areas, and into existing curriculum, and really matching them up with standards that you are already covering, like your Common Core standards and your NGSS standards. So everybody can benefit. It's just that we're not going to talk about integration as much at the high school level, because in high school, you have courses designated for computer science. You have to be a little more creative sometimes at our elementary and middle school ages. Just some real quick upcoming events for the LTC. We have our DigLitCon. It's next Friday. There's still time to register. You should totally register. It is an online virtual conference. We're going to be talking about everything related to digital literacy. Some of those things you can see there: digital citizenship, ethics, media and information literacy, visual literacy, all of the literacies. And there are a lot of them. So definitely join us. It's online, it's virtual. It's going to be amazing. We also have IETC coming up. It's an in-person conference in November. I don't know about you, but if you know who Matt Miller is, you are probably a huge fan like me. Dr. Monica Burns as well, keynote speaking. And we are going to have a ton of amazing information at IETC. There are going to be some wonderful workshops. There are going to be great breakout sessions. We're going to have some opportunities for networking and opportunities for fun. So definitely consider joining us for IETC as well. And now on to today's content. So as Brian said, I am Sarah Phelps. I am the Computer Science and STEM Program Manager for the LTC. I've been an educator for 15 years. Before joining the LTC, I worked at Triad down in Troy, Illinois. We're in the Metro East, so outside of St. Louis, but still in Illinois. I was a regular ed teacher for 8 years. I was the elementary computer science and STEM teacher for 5 years. And then during that time, I also did some informal education through robotics clubs, after school coding clubs, and we had some STEM enrichment activities as well. So I kind of saw a lot of different ways to incorporate computer science and STEM, K-5, and also in the middle school area. I did some of that informal education. After leaving Triad, I joined the LTC first as an instructional technology coach last year. I worked with 3 districts in St. Clair County just to support their educational technology integration, where we did some computer science and STEM integration, as well as just instructional tech. But I always like to say that I get my best experiences by being a mom of 3 boys. So a lot of the things that I used in my classroom or I talked with teachers about using, I tried out with them first. They all 3 really enjoy STEM and computer science, and they give me a lot of good, honest feedback about resources and tools. Whenever I get a new tool, we definitely get it out and we play with it. I'm a code.org facilitator, and in my new role will actually become the Illinois code.org regional partner for Illinois and Missouri, and I am a Google certified coach. You can follow me on Twitter. I'm trying to be much better about being active on there. But that is also my email, and I hope to invoke in you a trust and an open dialogue, so that if you ever need anything or you have any questions, you can absolutely reach out to me, and I can help you traverse this journey of computer science education in your schools. So before we get started, apparently I pasted something weird in there. Before we get started today, I want you to set up your why. I know that you are here probably because of the new standards being released, but I want you to think about, why did you sign up for this webinar today? Let's put our minds in a space of what you hope to get, and think about, what you hope will be a part of this today. Because if it's not there, I want that feedback. At the end, I'm going to ask you again, what do you need? So think about why you signed up for this webinar today and what you hope to learn. And if you feel comfortable, share that in that Q&A. I know that chat function isn't working, so put that into the Q&A. What are you hoping to learn today during this webinar? And just share that if you feel comfortable. I'm gonna expand here. This is my doctoral program professor, so I'll get rid of that while you're thinking. And if you feel comfortable, share with me, what are you hoping to get out of today? What are you hoping to learn? Oh, is the chat working now? Hey.
Yep, chat's working now.
I guess you can. Now you can put it in the chat. Awesome. And it's okay if you don't have specifics that you're hoping. I mean, it can be anything, but just kind of set your why. Why are you here? Did somebody make you come? That's okay too. You can say that. What do you need? What do you want to learn? Why did you come today? Very good. Oh, yes. Overwhelming information. I understand that as well. Just to share while you're kind of processing too, when I first started the elementary computer science position, I had to do some research on my own, and it is overwhelming. And even still, sometimes when you see all these amazing resources, you have to ask yourself, what is what I'm using what I want to be using? And how do I make this best for students? Because that's really what we want. We want our students to have this amazing experience. All right, you guys have some great whys, and hopefully today, even if you don't walk away with a complete understanding, hopefully, if nothing else, I've given you the confidence to know that it's okay, that this is going to be a journey. Just like technology, our understanding of best practices for teaching computer science are going to be changing, and there's going to be new things, and that's going to be great. And we're going to be, here's a computer science term for you. We're going to be agile. We're going to learn as we go, and we are going to improve as we go, and we're going to help our students get some brand new, amazing skills and hone some skills that you may not have even realized you were already honing for computer science. I already love this group because you guys are participatory, and I love it. All right, so let's talk about why we needed CS standards. Well, first of all, this is for preparedness, right? These are a research space to help students that are preparing for the workforce. We know that our Common Core standards, our NGSS standards, we're developing future members of society, and this is just another level to that. You would probably be hard to find an industry where computer science isn't a major component, where students don't need to understand some level of, even if it's just hardware, software, or understanding how to interact with the computer in a way that's safe and protecting information. All of these things you're going to see are related to computer science, and we want to make sure our students have all of the skills necessary to be successful. Another important thing for these computer science standards is to tackle this equity issue. Computer science is not new in public education. There are places that have been teaching it, but without standards and without any sort of guidance from the state, it hasn't necessarily been a priority. We know that in education, we have tons of priorities, and sometimes we have to pick and choose. But with computer science standards, we now have this kind of level of support, right, from the state level that says, yes, this is important too. We should find time and space for this. And that is going to increase equity so that all of our students have access to a knowledge base. We are going to eliminate this rolling the tech teacher dice and having, you know, one teacher who's really excited and interested in computer science and they're incorporating it into their classroom. And then the next student, the class over, never gets to hear anything about it because that teacher isn't very comfortable or doesn't feel confident. Standards try to kind of level that playing field for our students so that everybody gets that basic knowledge and then can make those conscious decisions about what they are interested in. Like everybody has those skills and can pursue interest from that point. And CS standards also give us clarity. They help us understand, like, what does computer science look like in kindergarten versus what does it look like when they're older? It helps us delineate what's not included because sometimes like we were just mentioning DigLitCon, there are a lot of computer literacy skills in the world. There's computer literacy, computer science, media literacy, digital literacy. You go on in the list. And so sometimes we're not sure that we're covering the things that we need to be covering. And it also helps establish age appropriateness, right? Sometimes we're overwhelmed by a concept. And again, maybe it's because we don't have background in it. I know I did not. I was not convinced that I was going to be able to teach computer science at first because I'm not a computer science major. I didn't do computer science. But once you start to dig into the standards and understand the skills and understand what's appropriate for your students and their age, I think you're going to find that you can actually rest assured you can do it and you can learn right along with them. Remember that term agile, that's part of it, learning as we go, and that's okay. And these standards give us that focusing on the right things. Okay, so we have a why. Here's another why. This report is from code.org. It shows us the state of computer science in the state of Illinois, and you can actually access the full report. It's a couple of pages long, and you can look at states around us as well in this report. But Illinois averages about 22,000 computing jobs a month, open jobs. Okay, so those are potential employment for our students. Those jobs have a decent salary. Now, don't quit on me and go join that workforce, okay? I don't want to be responsible for that, but this is a good workforce. It's a solid workforce. And again, it's connected to the things that impact our daily lives. But here's the number that hopefully is and kind of a motivator for you. Right now, Illinois is only graduating about 2,500 students to take those jobs. So in computer science, we are not graduating students to meet or to fill the jobs that we have available. This light blue fact is also pretty important. Illinois is not actually behind in the times as far as offering computer science courses in high school. 80% of Illinois students offer a school that offers computer science. That's a pretty great number, right? Obviously, with the new legislation, we want that to be 100%. But here's the important part. Even though 80% of high school students have that opportunity, only 4% of students are enrolling in that course. And I am a huge believer in that. That's because they don't know what it is. They have no foundation. They've not experienced it before they get to high school. And I definitely can relate to a student getting to high school, seeing my options and saying, I don't know anything about that. I'm not gonna pursue that. I'm not gonna take a chance and try that out. I would have totally been intimidated by ever enrolling in a computer science class. So what we want to try to do is give them opportunities to understand and experience computer science so it's not so scary. It's not so daunting when they get to that secondary level of education. Then they'll at least say, I know what computer science is and I love it. I can't wait to take another class. Or I know what computer science is and you know what? It was fine, but I wasn't that interested in it. And they choose something else. But it's their choice because they actually can make an informed decision. So CS doesn't just develop your coding skills. We're going to talk about that in a minute. When you think of computer science, you're probably thinking sitting in a computer, typing in semi-interpretable phrases and things like that with lots of colons and semicolons and capital letters in weird places. That's actually a very, very tiny component called programming or coding. CS is so much bigger than that. And hopefully today, by looking at these standards a little bit deeper, you're going to understand that computer science has built up tons of skills, and it supports a ton of skills. So computer science helps students develop problem solving and mathematical skills. They help them figure out their spatial awareness and reasoning skills. It helps them with metacognition, thinking about their thinking. It actually supports creativity. And there are reports, again, you can access the study here, that you can see how it improved student success in writing, reading, math, and science as well, because there are tons of overlapping skills and practices in all of those different areas. So what is required? If you're sitting here today thinking, you know, well, this is great, I know there are standards, but I don't actually know what they mean. According to the legislation, right now, computer science is not required for high school graduation. There are some states that require students take a computer science as a graduation requirement. We are not one of them. But computer science must be offered, at least one course must be offered and accessible to all students in grades 9 through 12. And then the requirement was that CS standards were passed, and that's what we see now. And they are created for K-12, again, to support that knowledge acquisition to that high school level course. But there's, again, no mandate for computer science in K-8 yet either. It's just a matter of, we know that it's important because it supports all of these wonderful skills that we're teaching anyway, and because we know that it is a future skill, it's a future ready skill that our students need. There are some wonderful links here if you want to know a little bit more about the mandates that are part of that, law that was passed. There's ISBE's fact sheet. You can kind of see some of the courses, and we're going to talk about that in a minute too. ISBE has kind of laid out what high school courses qualify as that computer science course, and you can find those course descriptions in the state course catalog as well. You might be asking, well, who's qualified to teach this? Because it's surely not me. And again, I've been there. I know that feeling. There is no endorsement for elementary. You can teach it just like you teach everything else. You are qualified to teach everything, master of all. If you are in a middle school or high school teacher, there are endorsements that you can get that endorse you to teach computer science. That does not mean that you cannot add computer science into your course if you're not endorsed to teach it. So if you are a math, science, if you have a advisory time that you think would be awesome to get these kids future ready, you can do that. If you want the endorsement for computer science, or if you're going to be the computer science teacher and you're going to teach a full class load of computer science, then these are the endorsements that you can get that qualify you. There's business marketing and computer education, business marketing, computer education with the business computer programming, computer science and computer applications. And you will notice that all of them have a test except for computer applications. I was actually talking to Jessie Irvin, who is the principal consultant for computer science for ISBE, and she said that that is kind of where they direct people if they're interested in becoming endorsed to teach computer science. That computer applications is a great starting place because there is not an exam. Again, more information linked there. This is just your high level summarizing. Okay, so I've just given you maybe some overwhelming news, but I want to let's pull it back into the good news, because I'm going to tell you, I taught elementary computer science and it is awesome, and middle school computer science is fantastic. And I hope today, if nothing else, I will have convinced you that it is so much fun and it is so worth your time to incorporate into your classroom. First of all, you are likely addressing some of these expectations already. And as we dig into the practices for computer science, you are going to see some similarities to things that you have read in other standards. You can integrate computer science, many of them, into content areas. And so you don't have to find more time. I know time is such a commodity in education. You don't necessarily have to find separate time. We can integrate a lot of these standards into the things that we're teaching already. You can address multiple standards at one time, just like you do in all the other subject areas. And here's the thing, they're organized by grade bands. You're not expected to take them from, you know, beginner to expert. Every grade band has some skin in the game when it comes to helping expose them to computer science. And there are a ton of amazing resources to use. And this is fun. It is so much fun. Computer science is going to engage kids who maybe don't otherwise have success in other classes or subject areas. My favorite story to tell is I had a student who very, very profusely disliked math. He would tell me regularly. It caused a lot of breakdowns. There was oftentimes crying, and he just did not enjoy math. And when the first time we did Hour of Code, we did Code a Snowflake, and that is the Anna and Elsa frozen hour of code. And this was back when I was just a classroom teacher. And it is directly tied in with geometry. It's all about angles and lines and turns and looping it so you make these amazing geometrical shapes. And we did this as a fun math enrichment activity. And it was an hour of code. And this was my very first experience coding too. And it took me every bit of an hour, maybe more. The child who hated math, right? He was bad at math. He finished that entire thing beautifully in 15 minutes. And then he proceeded to do it again because he wanted to make it better. And once he finally, like he was so excited, he printed his certificate. We sat down and we debriefed and we talked about how that was all math, but that maybe it wasn't that he was bad at math. It's just he needed a different way to experience math. And so you're going to see kids engage differently. It's going to cause students who maybe are always just the best at everything to have to think about things a little bit differently. You're going to see so much growth from your students when you incorporate it in coding and computer science. So let's talk about those terms because this is important. I think a lot of times when we say computer science, again, people think coding. They think typing in lines of text that tell the computer what to do. But computer science is way bigger than that. And there's also another concept called computational thinking. And so you can see these are all computer-related concepts. And you can see that coding is actually pretty small. It's a pretty small portion of what it means to introduce computer science to your students. Computer science is, let's look at some definitions here. Computer science is the study of computers. So we're talking hardware and software. We're talking about implementation and how we use this device to make things happen. We talk about their impact on society. How can we use computers to make the world a better place? How can we make the world more accessible with computers? There's a lot of kind of abstract thinking in computer science because we're thinking outside of the box. Computational thinking, on the other hand, actually involves no technology whatsoever. Computational thinking is actually just thinking like a computer. So we're taking complex problems and we're breaking them down. We're using all those problem-solving strategies like abstraction and decomposition and algorithms, all words that apply to all different subject areas. I know I taught decomposition and algorithms in math. I know we talked about patterns, which is another computational thinking concept in science. It's one of the cross-cutting concepts. So these two, computer science and computational thinking, are the bigger components. Coding in the middle there is just telling the computer what to do in the language it understands. Do you have to know that language too? Yeah, but we actually make it really simple because most of the coding kind of starts off with block-based. So you don't even actually have to know the syntax of how to tell the computer what to do. You really are leaning into that computational thinking and that computer science concept more. How can I solve this problem with a computer? How do I break this problem down so that I can use the computer to solve it? And finally, how do I write the code to make it happen? They play together, they're overlapping, but they're not all inclusive. So thinking is not the only thing. And as we look at these standards, you're going to see that it's only one of the practices. It's only one of the subcategories here. Now, what is important to notice is that none of these things, computer science, coding, or computational thinking, is just that everyday use of computers. It's not keyboarding. It's not getting online. It's not playing a game. It's not word processing or inserting pictures. Those are things that are more related to computer literacy or another one of the digital literacies. So we're focusing on the computer as kind of the thinking machine, or our brain thinking like a computer. Some more helpful documents that you might have seen. Again, these are going to be links that you're going to want to go to later. CS standards, that's just a link directly to the Illinois standards. So you can look at them, but we're going to actually show you a way better, and I want to say better, an easier resource to use that my amazing colleague, Eric, created. Actually, Eric has done so much work to help support this presentation today and all of the work that the LTC has been doing related to computer science. So I need to give him a shout out because I think he's on here. But he jumped on very quickly to help schools feel comfortable and confident with teaching computer science. So definitely shout out to Eric. In the middle there, you're going to see some fact sheets. These are all things that just help you kind of navigate that public act. That's where the legislation lies related to computer science and computer literacy. And if you want to dig a little bit more into now that you know a little bit more about what computer science means, what is computer literacy? That's probably the hardest thing, is to differentiate or discern the difference. There's the links back to those course catalogs and the course alignabilities for high school if you need to reference those as well. They were earlier in the presentation. But these are just some great resources all in one place. Sometimes when you need them, you got to go find them. I do every time. I have to go search every time I need one of these. And so here it is, all in one place for you. All right, so let's talk about these standards. So if you don't have a lot of computer science background, you may not realize that the national computer science standards have existed. I think the most recent edit or most recent release of them was 2017, at least that's the copy that I had. So our Illinois standards are based off of the CSTA standards, or Computer Science Teacher Association. And those standards, and then in turn, the Illinois standards, are based off of the K-12 framework for CS. If you know anything about NGSS, it's a similar model. The NGSS standards were based off of a framework for science, the K-12 framework for science. And we're going to talk about that framework because it is a very useful bit of information for you. So the original practices, the original CSTA practices, were these 7. Okay, so we have fostering an inclusive computing culture. Okay, everybody's invited, everybody's a part of it. Collaborating around computing. Recognizing and defining computational problems. Developing and using abstractions, big words, but don't be scared about those words. Abstraction, right? When we take something, we kind of break it apart and figure out what's important and what's not. Creating computational artifacts. That would be, artifacts are like programs or some kind of evidence of your work. Testing and refining those computational artifacts, always improvement, right? We're looking at and changing up and making it better. And then finally, communicating about computing. So if we look at these, they're color coded for a reason. So the 3 that are kind of orangey yellow, these are not related to coding. These are more of your computational thinking and your computer science components, right? They also link into our 21st century skills, those 4 C's: collaboration, communication, critical thinking, right? The blue ones, those are your computer science, like computational thinking, and also that computer programming, okay? Figuring out problems, figuring out how we should solve those problems with a computer, developing a computer program or developing a computer algorithm that's going to help us solve it, testing it out, and then refining it and fixing it. Illinois added 2 additional practices, and these are related to the future of technology. So we're thinking about how technology impacts our society, our culture, and our economy. And we're also reflecting on that process, that computational thought process of ours and others. Okay, so this is kind of the future of computing. There are concepts in the CSTA standards that then show up also in our Illinois standards. Okay, so computing systems, networks and the internet, data analysis, algorithms and programming, and then impacts of computing. So let's break those down a little bit, okay? Computing systems, those are the devices, they're the hardware and software, they're troubleshooting. There's a lot of overlap in computing systems with computer literacy, right? How do students use the devices effectively? How do we fix something when it's not working? How do we make things work the way that we want them to? Networks and the internet is all about connectivity, right? Network communications. How do we organize? How do we get information from point A to point B? We also bring in cybersecurity. There's also overlap here with computer literacy, also internet safety, also digital citizenship. Data analysis. This is where we get a strong tie-in to like science. Storage, collection, visualization, and transformation of data, okay? We use computers to collect data. Computers can't do anything that we don't lay out for them to do. We design what we want them to do. They can just do it faster than us. They can create models, and with some AI, they can actually create future models. They can make predictions. Algorithms and programming, that's where the coding comes in. This blue column is coding. This is where we're telling the computer what to do and how to do it. This is where we're using things like algorithms or step-by-step processes to solve a problem. We might establish some variables. So we want something to happen if. This is where we get our control and our program development in there. And then impacts of computing is all related to culture and our interactions and safety and ethics and how computers impact our world. As we look at these, we are really breaking into a lot of cross-curricular areas, right? Whether it is other ways that we're teaching about computers in our computer literacy, digital citizenship, or in our science, or if we're talking about social studies and impacts on our culture and how computers change the way that we interact with one another. Really, coding and typing up that code is just in that algorithms and programming area, okay? Train that computer. And I think that is probably one of the most stress relieving things to hear, because when we think of computer science and we think of programmers, we think of a language that we don't speak. But in reality, that's a very small part of it, or it's not the only part of it, I should say. And that's actually the fun part of it. So understanding how computers work and using them effectively is this computing system. And computer literacy skills, so much of that overlaps. And if you click on the computer literacy hot link here, it will take you to a wonderful computer skills continuum. If you haven't seen this, this is a continuum that ISBE created that talks about what these skills are. So everything from logging in and creating a safe password to understanding how to turn on or turn off a device, how to reboot it, how to install updates, they're all here. So that would be a whole nother webinar, but it is a great resource and probably things that you are already seeing your teachers tackle with students just because they use the devices, they talk about these things, you know, recognizing the parts and components of computers, again, so that students can use them. So awesome, 2 birds, 1 stone, okay? We're tackling the computing system as well as computer literacy skills oftentimes. Networks and internet, cybersecurity, again, this is where we're really tapping into that keeping yourself and your work safe online. There are wonderful connections to the computer literacy as well, but also digital citizenship and online safety. Fun fact, there's also a law related to internet safety that we have supposed to be incorporating in starting in 3rd grade. But there are wonderful lessons about that. Common Sense Media has wonderful lessons, K-12, that tackle digital citizenship and internet safety. The National Center for Missing and Exploited Children has wonderful cybersecurity lessons. They are tied into, you can tie these into a little bit of SEL as well, keeping yourself safe, knowing how to navigate online so that you are protected. These are wonderful mini lessons, or you can even have some like units of study or special class areas that you talk about these things. How does the internet work? How does my information get from point A to point B? And what do I need to do to keep it safe? Data analysis is a lovely tie-in with math and science because we are managing data. We're collecting it, we're storing it, we're displaying it visually. So you can tackle these skills with or without a computer. You're probably already tackling it without a computer. So now you can bring in a computer as well to digitize those displays of information. You can also then use data to help you kind of draw inferences, analyze trends and things like that. Math and science, we want to bring this in. We want our students to see computer science as a tool that lots of people use to in all of those job areas, right? If we want to see weather models, if we want to see population tools, you can show them real life examples of where data scientists have taken the data, that math and science component, and they have put it into the computer to make a visualization. That's a great way to show that connection. Algorithms and programming, this is your coding, okay? So think like a computer so you can train it to do amazing, awesome things. There are so many options. And we're gonna talk about some of those at the end here. And I I didn't even get all of them on there. I tried to stick to the ones that are generally free just because there are so many great resources here. Because this is probably the one that you're thinking, I don't know anything about this, and that's okay. You can actually teach algorithms and programming with a computer. That's what we call a plugged lesson. But there are also tons of unplugged lessons to support all these ideas too. And sometimes what is the most effective at teaching something that's unfamiliar, like programming, is to pair those plugged and unplugged lessons together. Introduce a concept with an unplugged lesson, and then show them how it works on the computer with a plugged lesson. And again, we'll look at some examples of that. We'll look at some resources for that. And finally, that impacts of computing. This was that extra area that Illinois added, that future computing. I guess impacts of computing is part of CSTA as well, but the future technologies was added on. But this is where technology meets society. This is our, considering how it's impacting the decisions that we make as a society, considering how we could use it, leverage it to maybe make the world a better place for people who are not having the best experience right now. We also talk about privacy and how, technology, we have to think about how that impacts us as well. What do we let people know about us? Not on the cybersecurity component, but like, what information am I sharing about myself when I'm using Facebook or I'm clicking on ads? We need to know about these things so that we can be informed voters and we can be informed participants in a digital age and digital world. Again, there are lots of lovely activities that go along with these. I'll reference back to Common Sense Media. Their Common Sense Education has wonderful lessons related to these things. You can do them as, again, SEL, if you have an SEL time to talk about things like impacts on society, right? How does this make people feel? How does this impact other people? You can do it through social studies and science and ELA. There are great articles about technology and the impact that it's having on humans and on society, both positive and negative, right? Have students really dig into how technology impacts them and it impacts the world. And also think about ways that we could harness it to impact it for the better. Emerging and Future Technologies is our Illinois edition. What's new? What's coming next? What do you think we should have? How do you think we should harness technology to improve our existence? And think about the future. What big things could we use technology to create? This again is also a great way to bring it into science, social studies, and ELA. So how do you read these standards? Because to get started with them, you have to be able to interpret them. And as mentioned, CSTA standards existed before those Illinois standards. So just because a resource is not out there aligning to Illinois standards, don't fret, because if it's aligned to CSTA, we can match it up. When you look at our Illinois standards, you'll see a grade band first, so it says K2. Then the content domain, so CS, computer systems, those match up to those colored boxes that I showed you. And then we have the number standard, so just 1, 2, 3. That just tells you, if there's more than one in computer systems, this is the third standard. And then we have the words. You'll even notice when you compare them down here, the words are the same. So the CSTA standards and Illinois standards even use the same vocabulary, same words. The only exception is that future and emerging technologies doesn't exist in the CSTA standards. The only thing that's different as far as the standard codes is that grade band. So if you see a CSTA standard, you're not going to see K2 or 3.5. You're going to see 1A or 1B or 2 or 3A or 3B. And it seems complicated, but it's actually really simple. So 1 means elementary. 1A is your early elementary, so K2. 1B is your later elementary, 3.5. Level 2 is middle school, 6.8. It's all by itself. And then level 3 is high school. 3A is something that would be 9 through 12, so it's more introductory. 11 through 12 is 3B, and that's going to be your more complicated or more advanced concepts. So you can take a CSTA standard and you can look at it and you can interpret it into the Illinois standards and vice versa. So if you find a resource and it's aligned to one and not the other, that's okay. So here is our next, action item. What are we going to do? How are we going to make this happen? How are we going to bring this in? How are we going to align a curriculum or create a curriculum that's going to be a pathway for our students to be successful so that we know that they are getting that foundation of computer science that will help them be successful, both when they get to high school and they can take those courses at the high school level, but they can also make that informed decision as a person going into the workforce. So number one, our first approach, make it make sense. As anything, you can't work with something that you don't understand. So we spent a lot of time kind of breaking down those standards. Hopefully this resource is something that you can come back to and you can reference. I'm also going to show you that K-12 framework because it also provides some wonderful clarification on some of the ideas that maybe you are not as comfortable with. Know your strengths. What are you already doing? Okay, and I'm going to show you Eric's resource that he created, which is an alignment resource or a computer science worksheet where you can look at your standards and say, okay, I'm doing that in social studies. I'm doing this in reading. Oh, we talk about patterns in science. And then look for things that you could incorporate a little more computer science in, or maybe it's just adding the computer science vocabulary. Okay, we talk about this, but I'm gonna introduce that term abstraction because that's what the students are doing. Let's call it what it is. And now we've really helped them understand how it applies to computer science as well as math or English. Okay, so look for projects that you're already doing some of these skills in, and then see if you can expand them or you can add a few more skills in. Remember, you can stack a lot of these contents or a lot of these standards. They go together. Also, look for places where maybe you could more easily integrate. So don't force it. Try to find places where maybe you're like, that works right there. Let's put that here, right? Don't force it in if it doesn't fit, because then you're not going to feel comfortable and the students aren't going to see that connection to it. Find places in lessons where the standards can be integrated easily. And then ask yourself, okay, what's left? What do I not have a spot for yet? I'm doing all these things, but I need to find a place for this, right? Find that gap and then find a resource to address it, right? Find the resources that can plug in your gaps to help you address the rest of the standards that you're not already addressing, okay? How do we unpack these standards? Because, right, number one is making sure that we understand what the standard is saying. The Illinois standards are lovely. And remember how I explained that they are, in fact, the same words as the CSTA standards, just that grade band is different. I like to look at the CSTA standards because they actually also provide a little bit of a reference for what the standard means. So when you are looking at standards, you can read the Illinois standards, but if there's something sticking out like that you're just not sure what it means, you can also go to the CSTA website and look at the CSTA standards. And when you look at them, as it loads, just a sec, you're going to be able to click on it. So when you see the standard, that's right there. That's kind of what you get with Illinois. You're like, okay, that standard makes sense. Select and operate appropriate software to perform a variety of tasks and recognize that users have different needs and preferences for technology use. Okay, that seems pretty straightforward, but you know what? I need a little more clarification. If you click the little drop down, you can actually get some examples of what that might look like, okay? And even, like as we said earlier, that grade band is not there. The CSTA standards will have it right here. So you don't have to remember what 1A means. It's also in the CSTA standards right here. So let's look. It says, oh, people use computing devices to perform a variety of tasks accurately and quickly. It's going to break it down. It's going to tell people, it's going to give you some examples of how this looks in the real world. So with teacher guidance, students should compare and discuss preferences for software and their primary functionality. What do you like to use? Like you can have a conversation about on your device, what do you like to do? Which tool do you like to use? It could be as simple as different kinds of games, but it also could be like, hey, we need to, we need to type this up. Which would you rather use, Notes or Google Docs? You can do this with any of these standards. You can expand and you can find out a little bit more, right? What are the appropriate components of a computing system that K2 should know? It lists them out: desktops, laptop computers, a tablet. So knowing the difference between a Chromebook and a tablet, or your mom's phone and your Chromebook at school, the keyboard of the computer, a mouse, printer. It's going to give you some specific examples of what they're talking about, and it's going to help you figure out what is age appropriate here. So the CSTA standards are awesome for that. Illinois does not have that expanded section where it will like kind of give you a little more information. However, you can also find that extended information in the K-12 framework, okay? The framework also will let you kind of dig in, and it will give you some more information, which is pretty great. So if we want to go to by the end of second grade, oops, I want to unselect all. Into second grade, and let's look at computing systems. Okay, so for devices, what do we need to know by the end of computer science or end of the grade 2 for computing systems? We need to know things like, what can devices do? Like, what can we use a device for? What can we, why do we need to use them? Sometimes when we don't give the computers the exact instructions that we want, it doesn't work, right? These frameworks, again, will break it down for us. It will help us understand what we expect our students to know. It'll put it into terms and into context for that each grade level. If you go, I promised you that Eric had made this amazing resource to help navigate all these things together. Obviously, you guys are very familiar with the Common Core standards, so look for overlaps there. As you read the computer science standards and maybe look at the expanded version or the framework and you say, hey, that sounds familiar. I think that that actually is part of what we are doing when we do this, like step-by-step directions. Oh, we do a how-to paper. Hey, we can put these things together, right? How can we integrate? How can we call out when we're doing a computer science skill when we're also doing another content area skill? But Eric did this amazing tool, made this amazing tool. We have this integrated view, okay? So he took all of these standards, and this was kind of inspired, the CSTA had something similar. And you can see, instead of having all of K2 and then having all of K3, you can use this view to be able to see, okay, what am I gonna do? But then how does that look different from what 3.5 is gonna do? And then how does that look different from 3.8? He also made a Google Sheets version, which is then able for you, and there's a better link, an easier link coming up in the presentation, where you can actually start to record some things like, okay, we do this with this unit, with this activity, with this book, or with this lesson. And you can start to actually call out how you're accomplishing some of these things so that you can feel confident that you're doing the things that you need to, that you're helping your kids develop the skills related to these standards. So that integrated view is amazing, and I will make sure to call out the interactive one that's later in this presentation. So you're probably still thinking like, I need to see an example. I need to see an example. These standards, there's a lot to them. So Eric has this beautiful example, and he totally came up with this, but I will tell you, this is actually a really cool lesson that I did a form of this with my, my 5th graders when I was teaching computer science as well. Because you're going to see things like using hardware, and you're like, what hardware? This is an easy, fun project that is a simple way to cover so many standards. And then we're even going to talk about how to tack a few more on at the end. So this is a project. This is a project Eric did with his class. This is a project that I did. So we have this existing project. That picture right here, this is a makey board. So this is a cool thing that plugs into your computer. Because in 6.8, the kids are supposed to be able to use a piece of hardware, something in the real world, to control something digitally, okay? So the existing project that we have is using the makey, which is our input hardware, to design a game controller that can be then used to complete a puzzle or a maze in Scratch, okay? So this is our project. This is our initial project. Super fun. It's combining some fun hands-on engineering, super simple to do, kids love it. So let's take a look at some of the standards, okay? So our computing systems, remember, these are the actual physical devices. Well, we need to figure out how to recommend improvements to these computing devices. And we can ask for input based on how our users are interacting with those devices. My mouse is too small, the controller is hard because my thumbs don't fit where they're supposed to go. We can combine projects that, or have combined projects that we incorporate hardware and we have software. So in this case, we're using Scratch, that's an online programming platform, with the Makey, that's the hardware. They exchange data. Systematically identify and fix problems with computing devices. This is going to happen with all of our activities because we want kids not to just say, okay, I did it once, it doesn't work. We want them to say, okay, I did it, it's not working, what do I need to do and fix it so that it will work? So right there, with this project, we are covering all three of those standards. All right, so let's bump it up. Let's bump it up a little bit. So we are designing a device or a game controller for a maze that already exists in Scratch, okay? So we are now gonna tie in all these algorithms and programming because we can ask the kids to remix their maze and make it their own. We can develop, we can just take a existing maze and add our own flair to it, or kids can look at the code of a maze and try to make their own, or they can do some research and they can learn how to make their own. They're gonna design a program that will, again, work with their Makey to play or move a object through this maze. Now, let's really bump it up. So we just tackled a ton of standards. We're coding, we're solving problems, we're using, we're doing some debugging, or we're, troubleshooting, but let's add even more standards, right? Because again, we've got lots of tie-ins with other things. And these are like definite guaranteed kind of project boosters where we take something from just being a standalone lesson to having greater impact. We are going to incorporate more standards. We can do that through a competition, who can design the best, the most unique, who can design something using only found objects so that we're not creating any waste. You can tie in entrepreneurship, right? How would you sell this? How would you market this? Who would like to test this and give you feedback so you can improve your project? We can talk at a social justice or equity lens. How can we design a controller that somebody who has maybe a physical disability could use easier? We can incorporate peer feedback, right? Interview somebody, get them to tell you what they like or what you could fix about it. And we can incorporate self-reflection. All of these things are like power-ups to a project, not only because they help you cover more standards, but they make these skills and these resources and these lessons that we're doing more meaningful and tied to the real work that people are using computer science for. So now if we created a survey and collected data from a focus group of game testers, so you made your controller and now somebody's going to use it and give you feedback on it, and you're going to maybe adjust or adapt. Or so we see our collaboration, we just pulled in impacts of computing. Maybe we can get feedback from somebody who, again, has a disability, an accessibility issue, where right now they can't do a maze because their device, their controller doesn't work for their needs. So now we can add something to increase accessibility. Here we go. We've thrown on another standard, all in the same project. We can even add in that discussion of like, okay, so you made this, what should you do with it? Should you sell it, or should you make this free to the public? Should you keep it private? Should you just keep it for yourself? If you shared it, what are some of the things that might happen, right? We got to think about this. We're having this discussion. So all of these things tie into this existing technology project. And most of those things that we just talked about, with the exception of building the maze yourself, are all things that you probably already feel very comfortable doing. Designing a new game controller, talking about how to improve it, talking about what can make it more accessible, talking about the impacts that it could have on society. These are all things, hopefully, that you are starting to say, oh my gosh, yeah, no, I can do it. I can do that. I'm already doing all those things. So we just took this amazing project and covered like 2/3 of your 6 through 8 computer science standards, right? It's pretty amazing. So you're probably thinking, okay, you are talking about all these standards. I'm feeling a little bit better, but what do I use to help me accomplish these? There are a ton of wonderful resources, and I have actually put on here. So code.org, boot up, Scratch. You can see this continuum. The arrow here is telling you who this is a resource for. So code.org, boot up, PD, Scratch Junior, boot up and code.org are K-12. They have resources and less for K-12. Scratch Junior is for your younger students. It's for K2, you would probably use it with 3. We've got Tinker, that's kind of, actually, I think Tinker goes all the way up to 8th grade. CS First and Scratch are ones that you can kind of start with that middle grade. Just because they started a middle grade doesn't mean that they're not for beginners. It's just that the interface is got a little more text, so your kindergartners are going to benefit from those K2 resources because there's less to read. We've got Code Combat, MIT App Inventor, Code HS. You'll notice that 2 of these are starred because those are the only 2 on this list that are not free, which is always amazing. There are so many amazing free resources and robust, amazing resources to help you teach. And even Tinker and Code Combat have free components that you can use in your classes as well. Tinker has a lot of wonderful cross-curricular resources to embed coding into science and math. So does CS First. So these are coding resources when you're looking for those activities that support coding. You can also think about adding in things for programs, for programming and that hardware software component with robotics and microcontrollers. Again, we can, a lot of these, we can incorporate into our content, Bbot, Botly, CodeMouse. These are for younger students. You can incorporate them into literacy by having kids like program a robot to go to a particular sight word or a particular word group family. We can combine them. Ozobots, I know we use Ozobots a ton. They have just a huge cross-curricular library of activities that we can do coding, and we can do other concepts and other standards that we need to cover. So each one of these is linked. You can explore these a little further. You might already have some of these things in your school district, and you can dig in to see what resources that they have to support you and this journey. Remember, as you're doing your standards alignment and you're saying, okay, do that, need that, here's where these resources might come in handy to fill those gaps. Okay, I knew that an hour would be short because this is so robust, but here's what I need you to do. You're gonna click on this Google form, and I wanna know, as the new computer science and STEM program manager, I want to help support you by bringing you what you need to know more about. Do you need more time to unpacking the standards? We just did it fast and furiously. Are you just getting to the point where you're like, I know a little bit, but I wanna know more? Do you need professional development related to a specific tool, a specific set of curriculum? Do you need more ideas on how to integrate content with computer science? I need to know those things because that's how I can then help and make sure that that professional development is available and that we're meeting your needs. I can throw this professional development out every week, but if I'm not creating things that are what you actually want or need, then it's not valuable to you. So this Google form, and I'll put it in the chat in just a second as well if you can't click that link. But this is just you don't have to give me your name and email, but if you want, or you have a specific request and you want me to get back with you, or you have a specific question, this form is open-ended. You can tell me what you need as far as resources, but you can also ask questions, or you can kind of tell me your concerns. Here's what I'm worried about. And we can start to work through some of those things together. And then here is how you stay in the know. What I told you today, there are so many things that can help support you in this journey. The LTC has a computer science and STEM resource database. It's going to link you up with some different curriculums, some different professional organizations, everything and anything that might support you as you are working with computer science. I have a Wakelet where I've just started throwing together as many resources as I can as well. They're usually things that I've used. So you can click on that and see if you find anything in there that you'd like. U of I has a lovely K-12 computer science resource online that you can look at. CS for All has a curriculum directory. So if you're considering a curriculum or you want to know more about a curriculum, you can go to their directory and see kind of what's out there, especially if you're looking for something, but you're not really even sure what you're looking for. You can go to their curriculum directory and see what's available. Connect with us in our network. We have a network meeting next week for computer science and STEM. This network meeting is a chance for you to connect, ask questions, share your struggles, share your wins and your experiences with one another. Computer science, because it's not been an established thing, I feel like there were probably a lot of teachers like me out there I was a committee of one. And so I felt like I was kind of on an island making decisions. And it's nice to be able to talk things over and to ask questions. And so we're giving a space for that. Once a month, we're going to have a CSTEM networking meeting. It's basically going to be a time for you to connect with people that are trying to do the same things that you are. And you can ask questions. You can ask them candidly, like, okay, have you ever used this? Did it work? And you can really hopefully just build your PLN related to computer science and STEM. You don't have to be a computer science teacher to join that networking meeting. You can be a classroom teacher trying to incorporate computer science. You can be an administrator trying to help develop a program for computer science. You can be an advocate for computer science. Come and help us just hopefully inspire teachers throughout Illinois to get excited about computer science and STEM. LTC has a CS and STEM community. The community is kind of like that asynchronous place to ask questions. So if you're not already a member of that, jump on there, because if the networking meeting is not for a couple of weeks, but you have a burning question, you can put it into the community and hopefully get some ideas or some responses there. Obviously, you can always email me as well. It's just that you're going to get a way better, bigger pool if you put it into the community. There are some amazing professional organizations that I highly recommend joining. CS for Illinois, CSTA, which is that Computer Science Teacher Association, free, everything's free. IDEA, Illinois Digital Educators Alliance. All three of those professional organizations cost nothing for you to join and are just going to give you access to more resources, not only like lessons and ideas, but more message boards where you can post your questions. You're going to see professional development come through all of those as well. So this is kind of your way to have access to probably more information than you will even know what to do with, because I know that's how I feel. But it's a great place. These are all places that you can go when you need just a little bit more. You want to process a little bit more. I did it. I mean, I'm over, but I still did it. I didn't keep you for 2 hours. I thought I had linked Eric's amazing resource earlier or later, and I was wrong. Let me see. Integrated view. There it is. Okay. So I do want to just take 1 or 2 more minutes of your time, because I feel like this is the resource that is going to help you take everything that we just talked about, digest a little bit, but start to call out the things that you're doing. This was back on slide, I'm back on slide 14, but Eric Santos put this together. It just has those standards, but you can make a copy for your district. And then you can start to check box and you can say, okay, select appropriate software. Yeah, okay, kindergartners have to choose the app when I tell them to do X, Y, or Z, check mark. You can put in their little notes so that you can say, okay, we do this here. We use this curriculum. Oh, that aligns with our SEL curriculum because we talk about don't talk to strangers online. You know, you can use this as a place to really interact. You have the standards here. And then if you are like, okay, hold on, I'm not sure what this standard means, I need more clarification, you can click the name of the subcategory and it will take you to the framework. And so then you can say, okay, what does computer systems mean at kindergarten? And you can actually come to the framework and you can see, okay, for devices, oh, yes. Okay, they have to follow instructions. Okay, got it. And like I said, this framework's even going to give you some examples of ways that you might even incorporate it into your classroom. So it's a fabulous resource. Eric did an amazing job. I recommend it to everybody. On the bottom here, you can see K2, 3.5, 6.8, and you can use this to help you as you are diving into these standards and making them, hopefully, you're really showing and combining them into the things that you're already doing, those amazing things. So, all right, I'm going to stop. Is anybody, Brian, are there any questions that you picked up on while I was, talking a mile a minute?
Absolutely. There's one question in the Q&A regarding those resources you shared in SOPA compliancy. So if you want to answer that, I'm also going to give everyone the opportunity to unmute themselves if they have a question, or you can put it in the chat or the Q&A, either one. But if you have a question you'd rather ask than type out, I'm going to give you an opportunity to unmute yourself here in just a second.
Okay, so SOPA compliancy is a tricky one. Code.org is SOPA compliant. Scratch, CS First, and Scratch Junior are sticky subjects. Your students can use Scratch and Scratch Junior so long as there's no signing in. So you can still use those, but you're not going to have student accounts. You're not going to create student accounts for that because they are indeed not. If you make those student accounts, those are not SOPA compliant, just because they did not sign the NDA or NDP. CS First is a question mark because it does fall under Google. And so whether or not it is covered by that Google NDP it depends on who you talk to. So I would say if you're not sure, I know Tinker, Code.org, or Tinker, Code Combat, Code Monkey, there are lots of coding resources that are in the database. Just more are the paid ones versus the free ones. So good question. Thanks, everybody.